Hello students, welcome to today's session of chemistry. As you all know, we have started study of 7th lesson of your syllabus, that is modern periodic table. Before starting today's session, we will just revise what we learned in the previous session. In the previous session, we learned the periodic trains of two elemental properties, that is effective nuclear charge and screening effect. What is effective nuclear charge then? Effective nuclear charge is the charge actually experienced by an electron. In a multi-electron atom, positively charged nucleus attracts the negatively charged electron moving around it in different orbitals. And one more force there exists there, and which is the force of repulsion. That is the force that exists between the negatively charged extranuclear electrons. And because of these two forces, exist simultaneously, the outer shell electrons, electrons which are in the outermost shell, they are pushed further away from the nucleus and they are held less tightly by the nucleus. Or we can say the attraction of the nucleus for an outer electron is particularly very less, or it is cancelled. And the net nuclear charge thus actually experienced by an electron is called extranuclear charge, or we call it Z effective. Actually, this Z effective is somewhat lower than the actual nuclear charge. Then what is shielding effect? The shielding effect is because of the inner electrons. The electrons which are in the inner shells. We have accepted the model of an atom where the centrally placed nucleus holds the electrons which are in the outer shells. The shell which is near to the nucleus has lowest energy, and as we move away from the nucleus, the energy goes on decreasing. The electrons in the outermost shell, which is partially filled, always, except noble gases, and the inner electrons or inner shells are completely filled, and these inner electrons, they act as a screen between the valence electrons and the nucleus. They act as a screen or shield, we can say. That means the positive charge of the nucleus gets distributed among these inner electrons, and hence the actual nuclear charge experienced by the outermost electrons or in the electrons in the valence shell is very less. Thus, these are the main factors: effective nuclear charge and shielding effect, which show periodicity. The effective nuclear charge goes on increasing across a period, because across a period atomic radius decreases, and down the group the Z effective or effective nuclear charge decreases, because as we move down a new larger valence shell is added in between, and the shielding effect of the increased number of core electrons affects the nuclear charge. What are core electrons? One student has a doubt. What are core electrons? Do you understand by that? Core electrons are the electrons which are in the inner shells. Outermost valence shell is far away from the nucleus, and in between the nucleus and the valence shell, the electrons present which add screening effect, those are called as core electrons, and those have very much effect on the nuclear charge or effective nuclear charge, that is much affected by the screening or shielding effect. Now, what we are going to learn in this session? In this session, we are going to learn about the periodic trends in physical properties. There are many physical properties of the elements, those show periodicity. In this session, we are going to consider the periodic trends in physical properties with reference to five important properties. Which are those? The first one is atomic radius, second is ionic radius, third one is ionization enthalpy, next is electron gain enthalpy, and the last one is electronegativity. These are very important basic or physical properties which show periodicity, and they have a larger or a prominent effect on all chemical properties as well. So these are the basic properties, and their trend should be learned carefully and try to remember that trend, because these properties have effect on all the remaining properties. So let us begin with the first property, that is atomic radius. Now, the quantum mechanical model of atom which we have accepted, that describes that the extranuclear part of atom around the nucleus, that is extranuclear, hence it is called extranuclear. That means the part of the atom which is around the nucleus is called electron cloud. Thus, that electron, because of this, there is no specific boundary which we can tell that this is the size of the atom, but the atomic size or atomic radius, then it can be estimated from the internuclear distance under different circumstances. Different circumstances means, in case of non-metals, in case of metals. So in case of compound formation, the radius is measured in different ways. Now, first case, we will consider about the non-metals. In non-metals, noble gases are also included, but we are not going to consider those noble gases. So, other remaining non-metals, the atoms of an element are bonded to each other by covalent bonds. Do you know covalent bond? That the bond because of the sharing of electrons. And the bond length of non-metals is considered as a sum of radii of the two single bonded atoms, and which is called the covalent radius of the atom. How? Let us consider this. Now, in case of chlorine, the atomic, it exists as Cl2 or chlorine molecule. The two chlorine atoms are bonded to each other by covalent bonds. Then what will be the atomic radius of the chlorine? That will be the sum of, or it is the internuclear distance divided by 2. Here 2 atoms are there, hence we are going to divide it by 2, and that gives us 99 picometer. Hence, because chlorine is a diatomic molecule, both the chlorine atoms are connected by a covalent radius, then the internuclear distance, that is the distance between the two nucleus, chlorine, the distance divided by 2, that will give you the atomic radius of chlorine. It happens in case of non-metals. Now, it is given here, the bond length of chlorine-chlorine bond is 198 picometer. Hence, the atomic radius will be 99 picometer. Now, what about metals? In case of metals, distance between the adjacent atoms in metallic sample is measured. One half of this is distance is taken. Metallic bond is different. It is not, there is no covalent bond or ionic bond is there. Metallic bond is a different concept. You are going to learn that in later, in different lesson. But now just consider that the metallic atoms are nearby each other, and the distance between the adjacent atoms divided by 2, or one half of the distance between the adjacent atoms in a metallic sample, is a atomic radius in case of metals. Now, atomic radius, hence the definition. Atomic radius thus can be defined as, it is the one half of the internuclear distance between two adjacent atoms of a metal or two single bonded atoms of a non-metal. So, we just concluded from the above discussion that in case of non-metal as well as metal, it is the 1/2 of the internuclear distance between two adjacent atoms in case of metal and two single bonded atoms in case of non-metal. Now, about the trend. That means what happens to atomic radius across a period and down a group. So atomic radius decreases across a period up to group 17 and then increases down a group. Up to group 17, which is group 18, it is noble gases. So we are not going to consider about the noble gases because they show extremely different properties. So up to group 17 we are going to consider as we move across a period, the atomic radius decreases while down a group atomic radius increases. Why? What is the reason? Now, as we move across a period, the two factors which are elemental factors which are responsible for showing this periodicity. The greater the effective nuclear charge, stronger is the force of attraction between the nucleus and the outer electron, and hence the smaller is the atomic radius. We just have seen that across a period, effective nuclear charge increases, and hence across a period the attraction between the nucleus and the outermost shell increases, and hence the atomic radius decreases. Now, as we move across a period, what about the screening effect? Screening effect caused by the core electrons remains the same. Why? Because we have seen that across a period the electrons are added in the same shell. That means valence shell remains the same. That means inner core remains same across a period, because in the second period second shell is complete, in the third period third shell is complete. We have seen that. So across a period, screening effect caused by the core electrons remains the same, and effective nuclear charge increases, and the net result is decrease in the atomic radius, because the more valence electrons are held more tightly by the nucleus. Now, what happens down a group? We have seen that atomic radius increases down a group. As we move down a group, in any group, the effective nuclear charge decreases, exactly opposite. And the shielding effect, that also increases, because as we move down a group, the extra valence shell is added every time. The valence electrons, thus, because of the increasing distance between the nucleus and the outermost shell, why? Because one extra shell is added every time. Now, for example, take first group. First group, after hydrogen, there is lithium, then sodium, then potassium. So hydrogen is 1s1, lithium is 2s1, sodium is 3s1, potassium is 4s1, 1, 2, 3, 4. That means extra shell is added. And hence, as we move down, the atomic radius increases. What about the ionic radius? Do you know how it is formed? By the transfer of electrons. If we donate an electron, then that atom gets a positive charge, and the one when we accept an electron, that gets a negative charge. Positively charged atom is called a cation, and negatively charged is called anion. Now, an atom forms a positively charged ion on the removal of one or more electrons, whereas a negatively charged ion, that is anion, is formed with gain of one or more electrons. Do you understand? Cation, how it is formed? By removal of an electron. And anion is formed by gaining of an electron. Now, what will be the trend? The ionic radii show the same trend as the atomic radii, because there will not be any difference. Only outermost electron we are going to remove. or we are going to add an electron in the outermost shell. Hence, strained will not be affected. What happens when an electron is removed from the outermost shell? The cation is always smaller than the original atom or parent atom from which it is formed, because an electron is removed. And because an electron is removed, it contains fewer electron, less electron than the original atom. But the nuclear charge is the same. That means number of protons remains same, and one electron is removed. That means number of electrons is less as compared to the nuclear charge. As a result, the shielding effect becomes less because electron is removed, and the effective nuclear charge is more within a cation. While an anion is always has a larger radius, or it is larger in size than the parent atom. At it contains now an anion formed by accepting an electron. So it always has more number of electrons than the atom. Because of these additional electrons, electron repulsion increases in core electrons, and that decreases effective nuclear charge, and hence the atomic size increases. So this is about ionic radii. Now, the next factor we are going to learn about and its strength is ionization enthalpy. What is ionization enthalpy then? Enthalpy is energy. Ionization enthalpy is the energy required to remove an electron from the outermost shell. When an electron is removed from the neutral atom like X, it gets converted into cation like X plus charge. Hence, this is the definition. The energy required to remove an electron from the isolated gaseous atom in its ground state is called ionization enthalpy. In short, energy required to remove an electron. It is actually the quantitative measure, and it is expressed in kilojoule per mole. Quantitative, we can measure it, and the unit for it is kilojoule per mole. Since electrons are lost one at a time, suppose Ca forms Ca plus 2 charge, calcium, by removal of 2 electrons. But 2 electrons are not removed at a time. Every time a single electron is removed. So, electrons are lost one at a time. Hence, when first electron is removed, it is called first ionization enthalpy. When second electron is removed, it is called second ionization enthalpy, and so on for that given element. Suppose one electron is removed, it is first enthalpy, hence it is H1, it is written delta I H1. What is I? I is for ionization enthalpy. 1 is for removal of first electron. Now we are going to remove another electron from this X plus ion. So X plus gives another electron and gets converted into X plus 2 ion. This is delta I H2. That means second ionization enthalpy, we can say. And ionization enthalpy is always positive. Why it is positive? Because energy is always a need to be supplied, need to be given. And when energy is absorbed, the charge is always positive. Since energy is always need to be supplied to knock out electron from an atom, hence ionization enthalpy is always positive. The second ionization enthalpy is larger than the first ionization enthalpy. So delta IH2 is always greater than delta IH1 because we are removing an electron from neutral atom, which is first ionization enthalpy, and we are removing electron from a positively charged ion second time, and that is second ionization enthalpy. So it requires more energy to remove an electron from a positively charged ion. As it is positively charged, it holds the electron more tightly, hence it requires more energy to remove an electron from positively charged ion. What happens to ionization enthalpy? That means strained. On moving down the graph, first ionization enthalpy decreases. Why? This is because electron is to be removed from the larger valence shell. Screening due to core electrons goes on increasing and the effective nuclear charge decreases down the group. These are the two reasons. Every time when a new physical property we are going to study, you have to mention the two elemental properties, what happens to them, and they directly affect the trend of these physical properties. So electron, as it is removed, and that energy is called ionization enthalpy, as we move down a group, a valence shell is added. That means the outermost shell goes further away from the nucleus, and hence there is a decrease in the effective nuclear charge, and screening goes on increasing. That means as the shell is increased, again few electrons are added to the core electrons, and they just the positive force of the nucleus gets distributed among these screening or these inner core electrons. And hence, as we move down the group, as an extra shell is added, decrease in the effective nuclear charge takes place, and hence it becomes easier to remove an electron. Hence, as we move down the group, ionization enthalpy decreases. The first ionization enthalpy increases across a period. The trend for ionization enthalpy across a period, it increases across a period. Why? Because as we move across a period, effective nuclear charge increases. Effective nuclear charge increases, and the core electrons, number of core electrons remains same, because across a period a shell is complete and the electrons are added in the same shell. Hence, core electrons will remain same, but the effective nuclear charge will go on increasing, and because atomic radius goes on decreasing, hence it becomes more and more difficult to remove an electron from the smaller atoms of those elements. Hence, the alkali metals, which are to the extreme left, that is in the first group, they have lowest ionization enthalpy, while the inert gases, they show highest ionization enthalpies across a period. So this is all about atomic radius, ionic radius, and ionization enthalpy and their periodic trends. We are going to learn about remaining physical properties in the next session. So, what will be the assignment this time? You have to define atomic radius as well as ionization enthalpy. Open your textbook. You will get everything there. And you have to explain periodic trend in all the three properties we studied today. That means atomic and ionic radii as well as ionization enthalpy. While explaining periodic trend, just give what happens across a period, down a group, and why. What happens across a period, suppose it decreases or it increases, and why, that also you have to explain, because the question is explain, so you have to explain. Understood? So this is all about today's session. Thank you.